Hello everyone. This video is particularly for those students who are moving from class 10 to class 11th. Here we are not discussing a particular chapter. I am dealing with only some technical words which we come across in different chapters. Because knowing some basic terms is essential before starting our regular class 11 syllabus. So I repeat, this is not the entire chapter. We are dealing only with some basic technical words which we come across in chemistry. And in this video, we shall discuss about some basics of acids and bases. I think you might have learned either in class 9th or 10th the definition of acid and base. Here in class 11th, we come across three different types of definitions based on three different theories. So what are those three theories? One is Arrhenius theory. Second one is Bronsted theory. The third one is Lewis theory. Now, in this video, we will not discuss about the Lewis theory and Bronsted theory. We shall discuss about the Arrhenius theory. Now, according to this Arrhenius theory, we shall define what is an acid and what is a base. And you know the basic definitions, but still I repeat them and I will go deep into the definition. What is an acid? Any substance which contains hydrogen. Any substance which contains hydrogen and which gives H plus ions, when dissolved in aqueous solution, that is called as an acid. What is an acid? Acid is a substance which contains hydrogen and it gives H plus ions in aqueous solution. What is aqueous solution? The solution which is made by taking water as the solvent. So whenever water is the solvent or any substance is dissolved in water, that is called as the aqueous solution. So wherever I get new words, I keep on explaining those terms also so that you will be familiar with all the technical words. Can you recollect some examples? Yes, one of the example is hydrochloric acid. Most of you know these examples. Then sulfuric acid, nitric acid. What is this one? CH3COOH. This is nothing but acetic acid. Then what is the formula of carbonic acid? It is H2CO3. Then this H3BO3. This is called as boric acid. That is the acid of boron. So these are some of the examples of acid. See, in all the cases hydrogen is present and all of them when dissolved in water they give H plus ions. Let's take for example hydrochloric acid. When this is dissolved in water we get H plus ion along with Cl minus. If we take the case of sulfuric acid, here we will be getting hydrogen ions and we also get sulfate ion. If you take for example acetic acid, that is CH3COOH, when this is ionized we get CH3COO minus and H plus. Here remember the name of this one, CH3COO minus. This is called as acetate. What is this? This is acetate. We come across this example in several chapters. For example, if I write CH3COONA, as sodium is present here, we call this compound as sodium acetate, isn't it? And another very common example, CH3COO C2H5. As C2H5 is the ethyl group, we call this one as ethyl acetate. So wherever we get CH3COO minus, that is nothing but acetate. Now let's understand the definition of base. So what is a base? Base is a substance which contain hydroxyl groups. Base is a substance which contain hydroxyl group, and these give OH minus ions in aqueous solution. So what is a base? Base contain hydroxyl group. What is hydroxyl group? It is OH group. OH group is called as the hydroxyl group. So according to Arrhenius theory, all the substances which contain hydroxyl group and gives OH minus ion in aqueous solution, they are called as base. Let us take some examples. You know the example of sodium hydroxide, then potassium hydroxide, magnesium hydroxide. We can take aluminum hydroxide, calcium hydroxide, and so on. So what is common in all the cases? It is this OH group. If you take the case of sodium hydroxide, this sodium hydroxide, when dissolved in water, it splits into Na plus and OH minus ions. So any substance which gives these OH minus ions in aqueous solution, that is called as a base. Same when we take the case of magnesium hydroxide, this magnesium hydroxide also ionizes in aqueous solution to give magnesium ions and OH minus ions. So that is about the basic definition about acid and base. Now let's discuss a very important topic related to this acid and base. That is strength of the acid and base. We are talking about the strength of acids and bases. So these are very basic points, but the concepts of this particular one we come across in several chapters. Let us take strong acid. We are talking about the strength. I will just explain what is the meaning of strength here. In acids, we have two different types. One is strong acid and second one as weak acid. So what is strong acid? We already know the meaning of acid. So now it's extension of that one. Those acids which undergo almost complete ionization, it is not 100%, almost complete ionization, which undergo almost complete ionization and gives more number of hydrogen ions. They should give more number of H plus ions in aqueous solution. So I am writing aqueous solution in this particular way. So what is strong acid? Those acids which undergo almost complete ionization and gives more number of H plus ions in aqueous solution, that is called as strong acid. So among the examples which we had learned earlier, the strong acids are, one is hydrochloric acid, then sulfuric acid, nitric acid. And remember one thing, this HClO4, this is called as perchloric acid. This is called as perchloric acid. Among all the known acids, this is the strongest acid. This is the strongest known mineral acid. So that is the strongest acid which we come across in our syllabus. So that is perchloric acid, whose formula is HClO4. Now let's see what is a weak acid. So the acid which undergo incomplete dissociation, or we can say it as partial dissociation or ionization. Both the terms are same. Dissociation and ionization means the same. So those which undergo incomplete dissociation and gives less number of H plus ions in aqueous solution, they are called as weak acid. So what is weak acid? Any acid which undergo partial ionization and gives less number of H plus ions in aqueous solution, that is weak acid. And now the examples will be acetic acid, carbonic acid, boric acid, then hydrogen cyanide, and so on. So these are some of the examples of weak acid. In the same way, we can also define the strong base and weak base. So now you try to define the strong base. What is strong base? It will be similar to that of the strong acid. The only difference is here we need to replace that H plus ions with OH minus ions, isn't it? So strong base is the one which undergo almost complete ionization and which gives more number of OH minus ions in aqueous solution. That is called a strong base. And the examples are, except lithium, all the other first group hydroxides, all the hydroxides of alkali metals, that is sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxides, all these are examples of strong bases because they ionize up to greater extent and produce more number of OH minus ions. And in the same way, we can define weak base, and weak base is similar to that of the weak acid. So it is again undergoing incomplete ionization and gives less number of OH minus ions in aqueous solution. So the substance which gives more number of H plus ions in aqueous solution, that is called a strong acid. The one which gives more number of OH minus ions in aqueous solution, that is called a strong base. If it gives less number of H plus ions, that is weak acid, and less number of OH minus ions, that is weak base. So strength means here we are talking about the extent of ionization. Stronger substances undergo more ionization and produce more number of ions, and weaker ones produces less number of ions because of less extent of ionization. And here the examples are, this is a very important example, ammonium hydroxide. Then we come across zinc hydroxide. We can take copper hydroxide and so on. So here the important point is the examples. We use these examples in different chapters. That is about the strength of acids and bases. Let's understand some more terms from these acids and bases. And one term is acid anhydride. We use these words in several chapters, but you will not come across these definitions or the meaning of the technical words in any of the textbook. So what is acid anhydride? Here, this is an oxide when dissolved in water. This is the oxide when dissolved in water gives rise to an acid. So this oxide becomes the anhydride of this particular acid. The oxide which when dissolved in water gives a particular acid, and that oxide is called as anhydride of acid. Now, you think in the reverse way. From the acid, when we remove water, we get this particular oxide, isn't it? So, whenever we remove water in chemistry, we use this word called anhydride. N means here removing and hydride means water. So, we are removing water from the acid. When we remove water from the acid, whatever is the compound formed, that is called as acid anhydride. Is it clear? Let us take examples. If I take SO3, which is sulfur trioxide, this sulfur trioxide, when dissolved in water, we get sulfuric acid. So, this SO3 is called as the anhydride of sulfuric acid. Clear? Let us take another example. If I take carbon dioxide, this carbon dioxide, whenever dissolved in water, we get carbonic acid. So, when we are taking this carbon dioxide and dissolved in water, we are getting carbonic acid. That is the reason why this carbon dioxide becomes anhydride for carbonic acid. See the common things in both the examples. From sulfuric acid, when you remove water, remove 2 hydrogens and remove 1 oxygen, then you will be getting SO3. You are removing water. That is the reason why this becomes anhydride of sulfuric acid. Again, remove 2 hydrogens and 1 oxygen. You will be getting carbon dioxide. This becomes anhydride of carbonic acid. The same way, we come across several examples, like if you take the case of phosphorus pentoxide, this is the anhydride of phosphoric acid. When we take phosphorus trioxide, this is the anhydride of phosphorus acid. This is phosphoric acid. And this is phosphorus acid. When we take nitrogen pentoxide and that is dissolved in water, we get nitric acid. So the anhydride of nitric acid is nitrogen pentoxide, and the anhydride of nitrous acid is nitrogen trioxide. In the same way, for the bases, we have the word called base anhydride. So how can you define the term base anhydride? This is also an oxide, isn't it? So the oxide that forms a base when dissolved in water, that is called as base anhydride. So what is the oxide which is giving rise to a base when dissolved in water? That is called as base anhydride. Can you recollect some examples? Yes. If you take the case of sodium oxide whenever dissolved in water, we get sodium hydroxide, isn't it? So this sodium oxide becomes the anhydride of sodium hydroxide. If you take for example calcium oxide whenever dissolved in water, we get calcium hydroxide. So this calcium oxide becomes the anhydride of this calcium hydroxide. For acids we call it as acid anhydride. For bases we call it as base anhydride. In general we call them as anhydride. Anhydride means we need to remove water either from the acid or from the base.